Now, what's happening behind the scenes is, for the last 3 years or so, the world is obsessed with the race of large language models. Who has the biggest model? Which benchmark the model's performing highly at? What tasks that LLM can do? And it's been a story about OpenAI versus Anthropic versus Google. Well, that race continues, but the frontier has now moved. There's a new race that's emerging, which is new types of models, new types of foundation models called vision language action models. These are AI systems that will see the world through the vision models. They understand instructions in language. That's the L, or the language component of it. And then they take physical actions. Mind you, these are models that are fundamentally harder. These language models that we know today, they predict the next token. VLA models, they take it a step forward, where they will predict the next movement that the robot has to undertake, and undertake and not only predict that next movement, but also take that next movement in 3D with the physics involved, as well as the consequences of taking that action. So whoever solves this problem will own the next decade in AI. And this isn't just theory, by the way. We are already beginning to see a Cambrian explosion that happened on planet Earth 500 million years ago. And just like that time, we are seeing an explosion of all niches being filled, all life forms happening all at the same time. Look at the diversity. With the emergence of these VLA models and giving AI a body, we're now seeing a full spectrum and diversification of these models. We have quadrupeds, we have humanoids, we have snakes, we have swimmers, we have drones, we have warehouse robots, we have surgical arms, we have remote surgical devices that are emerging, agricultural machines. Every form factor is being explored. This is evolution in fast forward, driven by AI instead of natural selection. So here is the emerging robotics architecture in the global ecosystem. So if there is an organization that's operating in a manufacturing and supply chain, they are going to be dependent upon or providing some form of compute. That's the shovels and pickaxe provider. So we are going to require a lot more compute than ever before, and all forms of it on edge and other embodiments of it. We are crucially also going to require new forms of subsystems and components that we did not have to care about in the LLM space. So that's certainly the sensors, the actuators, the motion providing the components providing motions, such as gears and bushings. Various forms of power will need materials for various types of components and alloys to fabricate different parts of the robots. Building on top of that is the perception layer. This is where we'll see emergence of vision systems. So think of this as the various types of cameras, whether it is regular cameras or thermal cameras. We'll see emergence of depth sensing devices such as LiDARs. We'll see adaptations and improvements in localization technologies such as radar and other sensor fusion or multimodal edge processing devices that are going to. Then comes the intelligence layer. This is where the foundation models or the VLA models will sit, along with an unforeseen demand and generation of data to train these devices. That's where we'll see true emergence of digital twins, synthetic data, and other forms of testing. And we'll explore all of that in a bit more detail as we go through this episode. We'll see emergence of a lot more control and autonomy driven by algorithms for things such as path planning, for decision making for these devices. And then we'll see emergence of software stacks that's going to emerge both in terms of middleware, so that we can do fleet management of these things. And then we'll see the new frontier of new types of systems integration that's going to emerge, full stack automation of these things, orbital launches, infrastructure that's going to provide ground stations, mobility devices, delivery logistics, etc., all in support of what we now call a robot today. That's going to be an actual application domain, where that could be the humanoid of tomorrow, the the robots in industrial warehouses, the autonomous vehicles, the UAVs, the devices used in defense, and so on and so forth. That is the seismic shift. For enterprises, what this picture represents is supply chain complexity. A robot may have the software from the US, actuators from Japan, Chinese actuators, and the assembly might have been done in Vietnam. This is going to be geopolitics and risk built into the architecture. So I hope it gave you a little bit of insight of the paradigm shift that's already happening within AI.